Hello, my name is Jim McVeigh, and I'm a prototyping solutions architect at AWS. This video is part of a series of videos about the OPA on AWS open source solution to provide AWS-related functionality in your Backstage developer platform. In this video, we're going to dive deeper into environment providers in OPA to describe what they are and how you can build and contribute your own provider to customize the solution. As described in previous videos, OPA on AWS is an open source solution to help customers build their internal developer platform and integrate with AWS. The OPA solution provides the infrastructure as code to run Backstage in AWS, provides Backstage plugins, reference implementations for source code management using GitLab, and an example repository containing samples of environment provider, and software templates. So let's take a look at an overview of typical workflows and use cases for environments and application deployment using OPA on AWS. We have a platform engineering team. The platform engineering role includes responsibilities to define the infrastructure where business applications can be run and can be accessed by clients and end users. In an AWS cloud scenario, this includes setting up accounts, network, routing rules, storage, compute runtimes, monitoring, access permissions, and other resources so that they comply with corporate and industry standards and regulations. Using OPA on AWS, the platform engineer can use their preferred infrastructure as code like Terraform, CDK, or CloudFormation to build standardized, compliant, and reusable assets for how an environment for applications should be modeled. This code can then be wrapped into Backstage templates for environment and environment provider types and made available through the Backstage platform. And once the templates are in Backstage, they can now be used to repeatedly stamp out multiple environments across multiple accounts and regions for various departments by way of GitLab pipelines. With the environments prepared by the platform engineering team and available in Backstage, the application developers can now use OPA on AWS and Backstage to create new applications with corresponding Git repositories and pipelines to easily deploy them into target environments. Now, we cover a lot more detail about the application developer experience in another video, so I encourage you to check that additional video in this series. For now, let's take a closer look at what's in an environment provider that the platform engineer builds and how that process works. What I'll describe in this overview is typical of an environment provider supplied in the OPA on AWS solution as a reference example. As we inspect what makes up an environment provider, it's important to remember that all of these AWS resources will need to be provisioned. Behind an environment provider is simply infrastructure as code to provision resources. If you need different resources or policies than those provided in the solution, it's absolutely possible to modify the code or write one to meet your needs. An environment provider starts with a target account where applications should be deployed. In this account, there will be two key roles created. The provisioning role is intended to be assumed by a CI/CD pipeline and will provision application resources into the environment. This role is used when creating new applications or when modifications to application infrastructure occur. The operations role is used when performing actions against your application resources. For example, if you modify the application's environment variable configuration, stop or start the application, or retrieve application logs, then the operations role will be used to perform those types of actions. It's important to keep in mind the distinction between these two roles so that the appropriate set of policies are attached to these roles and avoid having them be overly permissive. An environment provider will also contain region-specific resources. SSM parameters will contain configuration information about the environment, secrets manager stores any secrets, and KMS keys are used for encrypting data. There's also an audit table created for the environment provider, which is used to store audit entries, capturing actions performed against the resources and applications that run in the environment provider. And then within the region, the environment provider provisions network resources, including a VPC, one or more subnets, routing tables, and security groups. Also provisioned will be the runtime environment. Each environment provider typically provides a single runtime environment. To support running containerized applications, for example, there may be an ECS cluster provisioned. Or, if the intention is to run Kubernetes pods, then possibly an EKS cluster would be provisioned. With a high-level understanding of what an environment provider encapsulates, let's look at what it takes to surface an environment in Backstage. The OPA on AWS plugins for Backstage contribute 2 new entity kinds to support and model the AWS runtimes for applications. We've been discussing the environment and environment provider concepts, and these are also the names of the new kinds that are contributed to the Backstage software catalog. An environment kind has one or more environment provider kinds. Components and resources, such as AWS RDS databases, also have dependency relationships on the environment kinds. If you're not familiar with the Backstage entity model, I encourage you to read more about the life of a Backstage entity and the system model at the URL on this page. We'd like our platform engineers to quickly create new environments based on established templates directly from the Backstage UI. Therefore, similar to templates used by developers to create new applications, we're going to contribute templates to Backstage for creation of the new entity types we just discussed. Let's take a closer look at what would be included in a common repository representing software template for environment providers. Here on the left is a directory structure of which you might see in a repo for an ECS environment provider template. On the right is the content of the catalog info YAML file. Normally, in the repository containing template files, you would find placeholders for many of the property values which will be substituted during the scaffolding process. Here, I've updated the content with actual values to make the context more meaningful. Much of the YAML file follows the descriptor format for catalog entities as described in the Backstage documentation. Some unique metadata additions for the environment provider include a prefix used when naming AWS resources, such as SSM parameter paths, an environment type to indicate the type of runtime supported by this environment provider. Valid values include serverless and ECS, with additional support planned for the future. The AWS account and region specify the account and region where this environment provider's resources reside. The environment role is a role in the environment provider's target account, which will be assumed during the GitLab pipeline to provision the environment resources. A series of metadata properties use SSM parameter store keys to pull configuration information at runtime. This is where additional configuration information about the VPC, ECS cluster, IAM roles, and audit table is stored. Finally, there is a reference to the CloudFormation stack, which provisioned the environment provider infrastructure. A GitLab CI YAML file is included in the template repository to define the pipeline used to build and deploy the environment provider resources. This is a standard GitLab pipeline file and can be tailored to use your own build conventions and processes. Ultimately, the pipeline will need to perform actions to invoke the CDK or Terraform infrastructure code. In this example, the actual CDK code to provision the network and ECS resources is in a shared pipeline file in the common CI/CD folder. The stack parameters properties file is a key value properties file used by the pipeline to load environment variables required for pipeline jobs. Lastly, the template YAML file captures how the template will present its input form in the Backstage UI and the series of steps to perform when scaffolding a new environment provider. Most of the content of this file is omitted here since the schema and examples for template YAML files are well documented in the Backstage documentation at the URL shown. If you'd like to build out your own environment provider templates and the supporting infrastructure as code to provision AWS resources, I encourage you to browse the open source repository for the OPA on AWS solution at the URL on this page. You'll find a Backstage-reference folder containing several examples actually used in the solution. The common subfolder is where you will find infrastructure as code with CDK and Terraform samples. This code is pointed to and used by the GitLab pipelines for environment providers. The templates subfolder contains examples of environments and environment providers similar to what we've just walked through. That concludes the high-level overview of environments and environment providers and how platform engineers can use OPA on AWS to simplify the creation of standardized environments in the AWS cloud for their application developers. Be sure to watch other videos in this series to learn more about OPA and how it can help you scale your development.